to start here. Name, properties, shape. Alright, so the first thing we're going to do is a quadrilateral. Alright, so a quadrilateral is a shape with 4 sides. Alright, it's any shape with 4 sides. Okay? So now what are the properties of a quadrilateral? No. No. Sorry?
All four angles equals to 360.
Yes. Internal angles equal 360. Alright, are there any other properties of a quadrilateral? No. Alright. Let's move on.
Trapezium.
Trapezium, okay. Alright, so trapezium. So now let's draw ourselves a trapezium. Alright, so what do we know about our trapezium?
One way of opposite sides of parallel.
Alright, so AB is parallel to CD. What else do we know about trapezium? Alright, so AC is equal to BD. Alright. AC is equal to BD. What else do we know about a trapezium? Angle A is equal to angle B. Angle C is equal to angle D. Alright, so we've got A equal to B, D equal to C. Alright, what else do we know about a trapezium? Alright, what happens if I draw lines like this through my trapezium? Alright, so now I've got 4 triangles. So now I can say, and I label this O because it's at the center. So I've got O, 1, 2, 3, 4, A, 1, 2, B, 1, 2, D, 1, 2, C, 1, 2. So now that I have this, I can now say I've got Z. So B1 is equal to C2. B1 is equal to C2 because of my Z. So I've got B1 is equal to C2. What else can I say?
A2 is equal to B2. No, C2.
A2 is equal to
D something.
D2. Okay. A2 is equal to D2. Alright. Now I can say that O2 is equal to O4. I can say O1 is equal to O3. Let's put a quick reason here. This is vertically opposite. Alright, and this is alternate angles equal. Alternate angles equal. Alright, what else can I say about this? What else can I say? I can say that A1 is equal to B2. Nope, we haven't done that one yet. Alright, A1 is equal to B2, which means Wait, hold on. B2 is equal to C1. There we go. B2, C1. No, that's not possible. Alright, so that's what we can say about that set of triangles over there. Okay? Does that make sense? So you see how I've written all of these things out for us so that we can remember all of these things when it comes to the test. This is the kind of thing you need to memorize. Okay? What's our next shape?
Wrong.
You guys are quiet this morning. Sorry? Oh, so you got shy. Alright, after trapezium came parallelogram. Alright. So now we've got a parallelogram. So our parallelogram looks like this. Alright. Alright, so first thing I can say about my parallelogram is that AB is parallel to DC. And I can say AD is parallel to DC. Alright, and then I can say that I've got an O here.
AB is equal to.
Alright, AB is equal to DC. And AD is equal to DC. So all these ones that don't have reasons, you can just say properties of a trapezium. So this would be, my reason here is properties of a trapezium. Alright, properties of a quadrilateral. Alright, properties of a parallelogram. Alright, what else have we got? Alright, same as above, we've got V1 is equal to C2. Actually, let's start with A. DAB is equal to BCD. And we've got ADC is equal to ABC. Alright, what else have we got? Got O1 is equal to O3. We've got O2 is equal to O4. Alright, we have A1 is equal to C2. Let's move on. A1 is equal to C2, vertically opposite, sorry, alternate angles. Alright, A1 is equal to C2, another line And then we have C1 is equal to A2. Alright, so then we have B1 is equal to D2. And then we have those two are equal. So B2 is equal to D1. All right, we have so now we have congruent triangles. A, O, D is congruent to triangle C, O, B. But angle isn't a reason. You need angle, side. All right, then we have triangle. Okay, so therefore, OB is equal to OD. AO is equal to OC. Then we have triangle AOB congruent to triangle COD. For reasons, once again, angle, side. And that means that CO is equal to no, not DO. AO, yeah. CO is equal to AO. Alright, and DO is equal to BO. Alright, so if they give you a parallelogram, you can prove all of this.
Will we get it right?
So?
Will you get it right?
What do you mean, do you get it right?
If we do this.
Yes. Depends what they're asking you to prove. If I tell you to prove congruent triangles, you can now prove it from this. If I tell you to prove that sides are equal, you can do it. If I tell you to prove all of this stuff, you can now prove just from this study notes I've given you here. Okay. So, all the stuff that doesn't have reasons, okay, all of that, your reason will be properties of a parallelogram. Okay. You guys happy? Alright, next. Alright guys, does someone want to take a picture of this?
I'll take it.
I know I'm taking a video, but you know, in case someone doesn't have access to able to download the video. Alright, next is a rhombus.
Good job. So proud. She's stepping up to me. So proud.
Taking her place.
Always.
I don't know if you can pull her shoes back.
Yeah, she's the photographer.
When she's not here, then I'm
I'll
the
say quite
photographer.
literally, because you know, she's.
Yeah.
You know, so I don't think you
True.
can pull her shoes.
Yeah. Okay, now I'm.
Literally as well.
Yeah.
Alright, guys. So next we're doing a rhombus. Alright, so that means it looks like.
Still is. It's yours.
Alright guys, so properties of a rhombus. So there is our rhombus. So we have AB is parallel to BC. Alright, we have AD is parallel to BC. We have AB is equal to BC is equal to DC is equal to DA. Alright guys? Alright, so those are the properties that we know. Alright, what else do we know in a rhombus? We know that. Alright, so we know that O1 is equal to O2 is equal to O3 is equal to O4 is equal to. No, it's not. Right? Alright, I just drawn it badly.
Angles opposite are equal.
Yeah. No, it's true. O1 is equal to O2 is equal to O3.
And they're all
Guys,
90 degrees.
too much talking. Equal to 90 degrees. Alright? Keisha. Alright. Yeah.
Opposite angles are equal.
Yes. Alright, so D
C.
A B is equal to D C B and A B C is equal to A D C. Alright, so then we have AO is equal to OC, and we have DO is equal to DO. Those are all properties of a rhombus. Alright.
Okay.
From there we can say that A2 is equal to C2. And we could say that, alright, so now I've got A2 is equal to C2 from that set. And then I've got, wait, there you go, B1 is equal to D2. B1 is equal to D2. Alright, I have D1 is equal to B2. And then I have A1 is equal to C1. Alright. Now I have the same congruent triangles that I have before, which means all of those properties are the same. So I've got triangles AOD, I'm gonna write here, triangle AOD is congruent to triangle COB the same as before. A, so A. Now I have triangle AOB. It's congruent to triangle COD. Alright. And then I also, since I have that side is equal to that side, that angle is equal to that angle. Alright. And what else have I got? Alright, so if those triangles are congruent, let's see what else we can prove from there.
AO is equal to CO.
AO is equal to CO. Yeah, but that's given.
Oh, in the beginning, right?
Oh, there we go. So that gives us, now we've got triangle AOB is congruent to triangle COB. Right? Angle side side. Okay.
Madam, then there's also two bigger triangles. There's
Yes.
AC, ADC, and ABC.
So triangle, before we move on to that, we've got triangle AOD is congruent to triangle COD. Alright, so this means that all the triangles are congruent to each other, which means we have four identical triangles. Okay. From here, we have triangle ADC is congruent to triangle ACB, angle side side. We have triangle wait,
It's the same one.
we have triangle DAB congruent to triangle DCB. Alright. All of that can be proved from a rhombus. Alright, it's for this reason that they don't give you rhombuses in matric. They don't give you any kind of parallelogram in matric because it's too easy to prove stuff.
This is easy.
Yes, because it's all given to you. They tell you it's a rhombus. Alright? Does anyone have any confusion about how I got any of those congruent triangles? I need to explain how I got those triangles to be congruent. Keisha, I recommend more writing. Your desk looks very blank. Yes, very empty. Do you need paper?
Madam,
Yeah.
did you say A vehicle is congruent to A vehicle?
Yeah. Alright, guys, any confusion about how I got these? Do you guys need me to explain how I got these congruent triangles? Alright. So, I'm going to start with this one. So, I've got... No, I need more colors. Alright, so I start with AOD. So this is this triangle over there is congruent to AOD is congruent to COB. COB. Alright, so I've already got that angle is equal to that angle, and I've got that angle is equal to that angle, and those two sides are equal. Therefore, it's a congruent triangle. Next, I have AOD. Alright, congruent to this one. Alright, so I already have that angle is equal to that one's equal to that one, and that side's equal to that side.
Yes.
Alright, therefore it's a congruent triangle. So this is just one thing, this is double. Now let's go on to the next color. Now I've got AOB, AOB. AOB is congruent to triangle COB. Alright, so I've got one line in common between the two triangles. Okay? That line is equal to that line because it's given. That angle is equal to that angle. We've proven it.
Yes.
Therefore, it is congruent. Alright, now I'm going to prove that these two are congruent. So this is my double one again, and a double one again. Alright, so same reasons as before. I've got a line in common. Those two lines are equal because that's given. We've already proven that those two angles are equal. Okay. Good. Right, now I've got my last triangles. Now I'm doing these ones. Alright, it's congruent to that one. Okay, so I've got a line in common. These two angles are equal. Alright, because that's a property of a rhombus. We've already proven it. And that angle is equal to that angle. Therefore, it is congruent. So this is our green one. Okay. And then, yeah, I think I've got orange. All right, and then I've got this one is equal to that one line in common. That has angle is equal to that one because that's properties of a rhombus or parallelogram. And then I've got that angle is equal to that angle. Okay, now I have proven all of my triangles congruent. Next up, we have a rectangle.
Helen,
Yes.
after we done with this table, can are you gonna do like how it could be in like an example from like how it would be in the chest? Similar.
Yeah. All right, but the table is most of what we're going to be doing today. All right. Okay. So now we start. Now we've got a. So your reason here would be properties of a rhombus. All right. Next we have a rectangle. So, let's start again. Do you see how the first couple of reasons are the same every time?
Yes.
First couple of statements are the same. There's not actually that much learning that's different. So what you can do is you can go and underline the things that are different for the different shapes. Okay. So we have AB is parallel to DC. AD is parallel to DC. I'm just going to put A in totality, in completeness is equal to B equal to C equal to D is equal to 90. Alright. We have AD is equal to BC. We have AB is equal to DC. We have, okay, now let's start with our alternate angles equal. so we have, alright, and then we've got O. So O1 is equal to O3, vertically opposite. O2 is equal to O4, vertically opposite. And then we have A2 is equal to C2. Alright, that's alternate. Angles equal. We have B1 is equal to D2. Alright, so let's go and mark what we've got so far. So A1 is equal to C1. Then what did I say? B1 is equal to D2. And then we have D1 is equal to D2. And then we have A2 is equal to C2.
We did that.
When we did that.
Then we have A1 is equal to C1. Alright. So I've proved all my angles equal. And I've got my lines are equal. So, more lines that are equal. We've got BO is equal to DO. We've got AO is equal to OC. Remember, if I'm not writing a reason here, that means your reason is properties of a rectangle. Alright, so then I continue over here. I'm going to start proving congruent triangles again. Alright, AOB is congruent to triangle DOC. Alright, so my reason is I've got a side, it could just be side, side, side. Side, side, side. Now I've got triangle AOD is congruent to triangle DOC. Side, side, side. Alright. Is there anything else I can prove here?
The bigger triangle.
The bigger triangles. Okay, so now I've got triangle ABC is congruent to triangle ADC, and my reason is still side, side, side. I've got triangle DAB is congruent to triangle DCB. My reason is still side, side, side. Alright, I think that's all we can prove for a rectangle. Okay, you guys happy?
Yeah.
Alright, next up we have a square.
That's gonna be almost exactly.
Alright, so for our square, alright, so now we start again. Alright. Alright, we have, it's going to be very similar to our properties of a rhombus. So we've got AB parallel to DC, AD parallel to BC, AB is equal to BC is equal to DC is equal to DA. Alright, we have O1 is equal to O2 is equal to O3 is equal to O4 is equal to 19. We have D, so I'm going to do a full one here of A is equal to B is equal to C is equal to D is equal to 19. Alright. And then we now also have isosceles triangles. Alright, so AO is equal to BO is equal to DO is equal to CO. Alright, which means we have A1 is equal to C1 is equal to A2 is equal to C2 is equal to B1 is equal to B2 is equal to D1 is equal to D2. Okay, my reason here is isosceles triangle. Alright, do you get how that's an isosceles triangle? So, that side is equal to that side. Alright, that's a property of a square. Which means if that side is equal to that side, that means that's an isosceles triangle, so therefore that is equal to that. So that's why all of these, your reason is properties of isosceles triangle. Alright. Then we have, now we don't need to use our alternate angles equal because we've got isosceles triangles, so now we can just write out our congruent triangles. So triangle AOD, congruent to triangle COB, congruent to triangle, so AO. It's going to change this up a bit so I can just copy it. Alright, AOD is congruent to triangle, what did I say? COB is congruent to triangle AOB, congruent to triangle DOC. Alright, all the triangles are congruent to each other. Alright, so my reason is side, side, side. And then I have AO triangle ACD. It's congruent to triangle DCB. Congruent to triangle BAD. Alright, that should do it. Alright, so you guys happy? Properties of a kite. Alrighty, properties of a kite. Alright guys, so what are the properties of a kite? Alright, so we've got that is equal to that is equal to that. Guys, quiet please. And then we've got that is equal to that. Alright, so guys, properties of a kite. We've got AD is equal to AB. We've got DC is equal to CB. We've got DO is equal to OB. Guys,
Madam, how did you label the kite?
sorry?
A on top.
Yes, A, B, C, D.
No, D is not at the bottom.
D, A, B, C, D. Alright, and then I have D1 is equal to B1. Isosceles triangle. Guys, too much talking. D2 is equal to B2. Isosceles triangle. Alright? This is the last thing we have to do, then we're going to take a break. So just concentrate, this last little bit. Alright, then we have triangle ADO is congruent to triangle ABO. And my reason is angle side side. Alright? And then I have triangle DCO is congruent to triangle BCO. My reason is angle side side. Alright? And then I have, guys, so another property of a kite is that D will equal B. So I've got the whole of D is equal to the whole of B, which means triangle ADC is congruent to triangle ABC. Alright, so my reason is side, side, side. Okay. Then from that we can say A1, therefore A1 is equal to A2, C1 is equal to C2, okay, and I think that's what we've got from a kite. Oh, last thing we've got is O1 is equal to O2 is equal to O3 is equal to O4 is equal to 90 degrees.
Well done, Joe. First time.
Alright, those are our properties of a kite. It'll give you something like this. Alright. Alright, so it'll say this is triangle A, B, C, D, E. And it'll say that that is equal to that and that is equal to that. And it'll say prove that. The question will say prove that. And the question will say prove that the line joining the midpoints of two sides of a triangle Guys, quiet please. So,
The big
A,
triangle.
B, C, D, E.
Madam, is that in our textbook?
Yes.
Can you show me the page? Tell me.
Alright guys, it's page 220. the way you'll be getting this in your control test, because this is most likely going to come up in your control test. As I say, I haven't seen it, but mostly in geometry control test there will be a proof, and this is the only proof that you know. Alright, so it's very likely that this will come up. So it says, prove that the line joining the midpoint of two sides of a triangle is parallel to the third side and equal to half of the length of the third side. That's your question. And then they'll give you this picture to tear off the back of your piece of paper. Right, as like a last page that you'll then tear off. You will then draw on this picture. Alright, it's here, thrown away. Alright. And so what you do from there? Alright, you take your pen on this back piece of paper, which will be attached to the back of your test, and you draw a line that is equal in length to DE. Alright? And you join it to C. And you label that F. Alright, that is what you'll draw. Okay. From there, I will say that now I've got, and then I'll draw in here E1 and E2. So now, I'll start by saying E1 is equal to E2, because what I want to do is I want to prove these two triangles congruent to each other. Alright, that's the first step of this proof, is to prove that triangle EFC is congruent to ABE. So E1 is equal to E2, we know that. Okay, alright, because that is vertically opposite. Vertically opposite. And then we know that AE is equal to EC, alright, and that's given. And then remember we drew DE to be equal to EF. So DE is equal to EF. Therefore, and my reason is construction. Alright, my reason is construction. Alright, so now, therefore, triangle AED is congruent to triangle ECF. Alright, so I've just proven that. And I've written it in this order because that is the order that is that the angles are equal to. So that side's equal to that side, so that's why I started with AE and EC. Okay, when writing out my congruency. And my reason is angle side side. Alright, so now I have those two angles equal. So now that means that if that is true from there, I then say that EDA is equal to EFC. So I can draw a little 1, 2, and a 1 and a 2. So now I can say D1, therefore D1 is equal to C2. Alright? D1 is equal to C2, therefore, alright, so if D1 is equal to C2, we have parallel lines. Okay, right, where are the parallel lines going? My brain's just broken. Sorry, it's not C2, it's F. Yes, that makes a lot more sense. And A is equal to C2. Alright, so E is equal to F. So now we've got that one and that one. Alright, so now we've got that angle equal to that angle. So now we've got a N. Do you see the N? Here's the N. Goes like that, like that, like that. Okay. You see the N. Okay. Or a Z or whatever you want to call it. Alright, therefore, AB is parallel to FC. Alright, so and my reason is alternate angles equal. Alright. So now I have BD is equal to DA. BD is equal to DA. BD is equal to DA. My reason is given. Alright? And I have BD is equal to FC. BD is equal to FC. So I have basically it goes AD. D is equal to FC because of my congruent triangle. So triangle AED is congruent to triangle ECF. Therefore, BD is equal to FC. Alright, do you see that? Alright, so basically what I've done now is I've said, we know that those two are equal, right? We know that those two are equal, and we know that that is equal to that because of our congruent triangle. Okay? So therefore, that is equal to that. So BD is equal to FC. So now I can draw another two lines there if we want to. So from there I can say, therefore, BFC DFCB is a parallelogram. Alright? Because I proved that these two sides are the same length and that they're parallel. Bless you. Alright. And so now that I've proved that, I can then move on to so if this is a parallelogram, that means that DF is parallel to BC. Therefore, DF is parallel to BC, and therefore DF is equal to BC because of properties of a parallelogram. So, DF is equal to BC, and then from there, we know that DE is equal to EF. So DE is equal to EF, and this is my construction. Therefore, therefore, DE is equal to, wait, which way does it go? Go remember the way it goes, I always forget its proportion. DE is equal to half BC. Half BC. Okay, do you guys understand how I've done that?
No.
Alright. Where did you get confused?
That one day, what DFC
Say when?
parallelogram.
Alright, parallelogram. But how I proved there was a parallelogram. Okay, so basically what I did is I proved that AD is equal to, AD is equal to BD, and that is given. Alright? And FC is equal to AD because these two triangles are congruent. Alright, therefore, BD is equal to FC. Alright? So if I have these two lines are equal, and I've already proved that, where is it? AB is parallel to AB. It's parallel to FC. That means I have a set of parallel lines and a set of sides that are equal. And if I've got both of those things, that means I have a parallelogram. Okay? Because I have two properties of the parallelogram, which is sufficient. Alright, so then from there, so that's how I prove that it's a parallelogram. If it's a parallelogram, that means that is parallel to that, and that is equal to that. So it means that BF is parallel to BC, and it is also equal to BC. Alright, because that's a property of a parallelogram. Alright, that's why I did that massive table with all those properties in it, so we know the properties already. Okay, from there, I said that DE is equal to EF, because I drew it that way, construction. Alright, and since DF is equal to BC, DE is half the length of BC. Alright, and that is my proof. Alright, if you don't understand it, the thing I recommend you do is just memorize it. Okay. Alright, do you need me to explain it again?
If we don't know it, we can memorize this.
Yeah. You can memorize this. If you don't understand it, memorize this. 10 marks in your control test.
Now we don't really need to copy this down because we already copied it down with our box.
Yeah.
What is the last thing you wrote?
Alright, I said DE is equal to half BC.
Except for gyro.
Okay. Is there any point that I can explain again to you guys? Alright. Rahim. Rahim. Less sulfur and more work. Alright. So now what we're going to do is we're going to go on to check your skills.
How many marks could that be?
10.
You're 3 marks.
Yeah.
If you learn it off, I'm not maybe just the three.
Yeah, so this is 20% in your test.
What?
Possible 20% in your test. Okay, so guys, quiet please. Alright, so you have a shape that says K, O, that's O, P, M, N. 1, 2, 1, 2, 3, 1, 2. And we're given that this is a parallelogram. So K, P, M, N is a parallelogram. Alright guys, quiet please. And then so ON bisects K and M and OM bisects NMP. Question 1. Show that norm is equal to 90 degrees. 3 marks.
Show that long.
Norm, yes. NOM is 90 degrees. How do we show this now? Alright, so first thing we have to do is we have to remember that this is a parallelogram. So we've got to think of all our properties of a parallelogram.
We only have one, 360 degrees.
No, parallelogram. You're thinking of quadrilateral.
So there's a long story.
Yeah. So we've got this side is parallel to that side. We've got that is parallel to that. That is equal to that, guys. Shh, too much talking. And we have that is equal to that. Alright. So now, how are we going to prove that this is a parallelogram? Congruency. So, prove congruent triangles. Okay? Guys, so what I'm first going to do is I'm going to look at my alternate angles equal. So, I've got O1 is equal to N1. Alright? Which means that O3 is equal to M1.
Yeah.
Alright? So now, what else do I have? Alright, so now I have to prove that it's O2 is equal to 90 degrees. Let's see what else I have. So I know that K is equal to M and D is equal to N. Alright. So now, can I prove congruent triangles from this?
Yes.
Do I know that KO is equal to OP?
K,
Yes.
How?
Common.
KO is equal to OP. Are those two lengths the same?
No.
I don't know, are they?
we
So it
have
says
not been given.
it's not been proven that. We don't know that KO is equal to OP. Alright.
Question is that. I'm really stuck. So this is the answer.
guys. So, what it does tell me here is that ON bisects KNM and OM bisects NMP. Alright? So that tells me that N1 is equal to N2. Alright? N1 is equal to N2 because ON bisects KNM. Okay. And we also know that M1 is equal to N2 ON bisects KNM. Sorry, KMP. Alright. So we know that. What's up?
They're not together. K and M are not together.
What do you mean?
K and M are not together.
Oh, sorry. NMP. Alright? So, that means that, so if that is equal to that, alright? So now we have N1 is equal to O1, right? So now, we'll say N2 is equal to O1, alternate angles equal. Alright, and then there's a better way to do this. So, what we do, we say let N1 equal X, let M1 equal Y. Alright guys, finish talking? N1 equal X, M1 equals Y. So now I have 2X plus 2Y is equal to 180 degrees, and my reason is co-interior. Alright, co-interior angles equal 180 degrees. Because I have these two parallel lines, there's my U. Okay, so that plus that is 180 degrees. So I've got 2x plus 2y is equal to 180 co-interior.
Madam, why 2x and 2y?
Because n1 is equal to n2, and I said both of them are x, so it's 2x. m1 is equal to m2.
Oh,
I said both of them are x, so
why?
I mean both of them are y, so I've got 2x. So then I've got, then I'll say, therefore, x plus y is equal to 90 degrees. Alright, I just factorized it out. I factorized 2 out of this side and divided 180 by 2. Okay? From there, what I then, if x plus y is equal to 90 degrees, that must mean O2 is equal to 90 degrees. So x plus y plus O2 is equal to 180 degrees. Angles in triangle. Alright? Therefore, O2 is equal to 90 degrees.
Yes.
Now, our next one says prove next one says prove that O is the midpoint of KP. Let's see how many marks this is for.
10 marks.
6. Alright, so this is for 6 marks. Alright, so guys, just so you guys know, if it's for 3 marks, it should have taken you 3 minutes
2.
to do.
Damn.
Sorry? Yeah. Alright, so prove that O is the midpoint of KP. So now what we have to do is now we have to prove congruent triangles. Alright, guys? So we have,
Focus.
I'm gonna write on red with red my answer. So now I'm gonna say N2 is equal to N1 is equal to O1. Alright, and that's alternate angles equal. And then I've got M1 equal to M2 is equal to O3. Alternate angles equal. Alright, so I've got PM is equal to KN. Alright, properties.
Is there a shorthand for that? Crop off.
I don't know.
Properties of mass.
Alright, properties of a parallelogram. Therefore, we have PMO, triangle PMO is equal to, is congruent to triangle KN. No, wait.
Yeah.
That's not true. I haven't proved it yet.
What about those after mistake?
Yeah.
Isn't it a parallelogram? So the corners can't be 90. The angles on the sides.
Yeah, those aren't 90 degrees.
Is it 90? Because they said 2 needs to be acute and 2 needs to be obtuse.
Yes, that is true. So they're not 90 degrees. X plus Y is 90 degrees. Not, which means that's 90 degrees. It's not that. That's 2x.
Oh, I see. Yeah, I see.
You see?
So it's both of them combined. Like,
Yeah.
that side is half.
There needs to be an obtuse N and P are obtuse and P and M are obtuse.
No, I think we have to N2 and F1 both of them together.
Yes.
Yeah, because
So, no. KP is equal to NN. Not necessarily.
yeah.
N equals to 90. How does it
Okay, I see it. So guys, quiet please. So here we have, guys, we have O3 is equal to M2. Alright, we've proven that. So therefore, so O3 is equal to M2, therefore OP is equal to PM. Isosceles triangle. And same thing on the outside. KO is equal to KN. Isosceles triangle. Alright, because we've proven that that is equal to that is equal to that, which means those two sides are equal. Right, because that's an isosceles triangle. So therefore, if KO is equal to KN and OP is equal to that one, those two are equal to each other. That means that those two are equal to each other. So therefore, KO is equal to OP. All right.
Yay.
I'll explain it again. All right, so the way it goes is, it says prove that O is the midpoint of KP. So there's O and here's KP. First we say that N2 is equal to N1, all right? We proved that over here. All right, and we know that N2 is equal to O1, all right? Alternate angles equal. All right, so therefore, N1 is equal to O1. All right, so if N1 is equal to O1, that means that Kn is equal to Ko because isosceles triangle. Then we have M1 is equal to M2. We've proven that already. And we know that M1 is equal to O3 because of alternate angles equal. Therefore, M2 is equal to O3. Alright, therefore, OP is equal to PM, isosceles triangle. Alright, and PM is equal to KN, properties of parallelogram. Therefore, KO is equal to OP.
Well done, madam.
Alright, shall I write it in that order? Okay, I'm going to rewrite it in that order.
Yes.
Guys, quiet please. N1 is equal to N2, proven. N2 is equal to O1.
Now, so it's no longer alternative.
Yeah, it is, look.
You said
I'm adding extra steps that you don't necessarily need. Okay. Guys, I'm rewriting the proof in a longer step so you guys can understand it a bit better. Alright, so therefore, N1 is equal to O1. Therefore,
it's in the wrong one.
Kn is equal to Ko, isosceles triangle. And we go with our next one. M1 is equal to M2, proven. M1 is equal to O3, alternate, angles equal, and therefore M2 is equal to O3. Therefore, OP is equal to PM. Alright, and my reason is isosceles triangle. And then I have KN. KN is equal to PM, properties of parallelogram. Alright, therefore, KO is equal to OP. Alright, that's the longer proof.
Let's take a photo.
Alright guys, quiet please. So, this is our next one. So in triangle PQR, A and B are the midpoint of sides PQ and PR respectively. AR and BQ intersect at W. D and E are points on BQ and RW respectively such that WD and DQ, WD equals Q2 and WE equals ER. Alright, so I'm use new colors here. That's 1, 2, 3, that's 1, 2, 3, 4, 1, 2, 3, 4. Alright, so that is the shape that we are given. And then we only have one question. Prove that ADEB is a Alright, prove that ADEB is a parallelogram. Alright, this is what we have to do now. And this is 5 marks.
I'm gonna wait till we have
Alright, so we are proving that this is a parallelogram. Okay. So we start by saying that AB is parallel to QR. AB parallel to QR and its midpoint.
Yeah.
Okay, midpoint theorem. So from there,
Do we say that it's half of that one because of midpoint also?
yeah, so AB is equal to half of QR. AB is equal to half QR. My reason is still midpoint. Okay. AB is half of QR, midpoint theorem. So from then I say, alright guys,
Do we have to work out those triangles?
so no, what happens now is now we have two triangles. So we have,
None of these two small ones on the side.
guys quiet please. So do you guys see this triangle over here?
Yes.
Alright, so we've got two triangle, another triangle. So DE is parallel to QR. Alright?
Midpoint.
DE is parallel to QR because midpoint. Alright, therefore, AB is parallel to DE. So now we have one of the facts proving that is a parallelogram. But we are only halfway there. Alright? Now we need to prove that they are the same length. How do we prove that they are the same length? Alright, so it's not going to be congruency. So we're going to say that AB is equal to half QR. Alright, midpoint.
And the other one's also half of that.
Exactly. And DE is equal to half of QR, midpoint. AB equals DE. Therefore, ADEB is a parallelogram. Okay.
Madam, it is not a rectangle.
Sorry?
It is not a rectangle.
All rectangles are parallel.
Yes. Alright, so it may be a rectangle as well, but it didn't ask us to prove that. It asked us to prove it's a parallelogram. So we don't need to go any further. Alright, so this is our next question. Guys, quiet please. So, our next question says, in the diagram below, D is the midpoint of side AB of triangle ABC, and E is the midpoint of AC. DE is produced such that, to F such that DE is equal to EF. CF is parallel to BA. Write down reasons why ADE, so number one. Write down a reason Okay, I don't like this one, so I'm going to do another example with it. So it's write down a reason why triangle ADE is congruent to triangle CFE. One mark. Guys, one mark. Write down a reason why triangle ADE is congruent to CFE. So we've got ADE is congruent to CFE.
Do we just like side and side?
Yeah, exactly. So we've got two sides, another two sides, and angles. So it'd be angle, just go E1 equals E2, side. Alright, so now I'd say DE is equal to EF, side AE is equal to GC. Okay, write down a reason why DBCF is a parallelogram.
Opposite sides are parallel and equal. Do we have that?
Write down a reason why DBCF is a parallelogram. Alright. DCF. So we've got DF is equal to BC. Alright. And then we have DB is parallel to FC. Alright, those are our reasons.
You only need two to prove that a shape
Yeah.
is a shape.
The thing is, it's only one mark.
Oh.
So go by your mark allocation. Alright, I'm going to do another one because I was far shorter than I expected it to be. Alright, so in the diagram below, PQRS is a parallelogram.
Madam, is this another diagram?
Yes. PQRS is a parallelogram, which means that is parallel to that and that is parallel to that. Alright, having diagonals, those and those intersecting at M and B. So if the diagonals intersect, that means we've got that is equal to that is equal to that. Alright, B is a point on Q such that SBA and RQA are straight lines and SB is equal to BA. So SB is equal to BA. So I'm going to start using more colors. This is why we need colors. So SB is equal to BA. Okay. SA cuts PR in C and PA is drawn. Alright, so now I also have that is equal to that and that is equal to that. Question 1 says, prove that SP is equal to QA. Alright guys, prove that SP is equal to QA, 4 marks. How do we prove that SP is equal to QA? So here's QA, and where's SP? SP is equal to QA. So we know that SP is equal to RQ. So I'll start with SP is equal to RQ, and that is properties of parallelogram. Alright, and what else do I know? Okay, so I think the way we're going to have to do it is prove congruent triangles. Alright. Yeah, that's how we're going to have to do it. We're going to have to prove congruent triangles for ourselves. Mm-hmm.
The things in brackets is the reasons, am I right?
Yes.
So I think the people must be just put it in brackets and must be right like.
Alright, so guys, in the paper you can draw it as a table or you can put it in brackets. Alright. So SB is equal to BA. SB is equal to BA given. Alright, SB is equal to BA given. Alright, and then the next step says that QR is equal to QA. QR is equal to QA. Alright, so my reason for that is midpoint theorem. Okay. Did you see it? Because I didn't see it. Look. These two lines are parallel. That is equal to that, which means that triangle has midpoint, that line over there. Okay, do you see that?
Yeah.
Alright, so I've got a triangle that goes like this. Here is my triangle. And I have that line is equal to that line, and that line is parallel to that one, which means RQ must be equal to QA. So I say here, RQ is equal to QA, and my reason is midpoint. Alright, midpoint theorem. So now that I've got RQ is equal to QA.
You can say that SP is equal to SP was equal to RQ.
Alright, so QR is equal to SP. So therefore, now I can say SP is equal to QA. Alright, so you see how here SP is equal to QA because RQ is equal to RQ. Alright, so there's my proof, there's my 4 marks. Alright, the next question is prove that SPAO is a parallelogram. O.
Yeah, what is
SPAQ. SPAQ is a parallelogram. So here it is, SPAQ. So here's our parallelogram that we want to prove. Alright, so we already have SP is parallel to QA. SP is parallel to QA, and that is given. Alright. So if it's not given, it's properties of a parallelogram. Alright. So now we have those two sides. And then we also have SP is equal to QA. Proven. Alright? And there it is. 2 marks. Alright guys? Be concentrating. Alright. So now I can say therefore SPAQ is a parallelogram. Alright, finally it says prove that AR is equal to 4MB. Number 3, I'm going to write it at the top.
Wait, don't erase it. I want to take the photo. This is part of this one.
Photos have been taken.
What's wrong with that one?
Alright guys, prove that AR is equal to 4MB.
Please send it to me.
Yeah, hopefully it's not. My calculator.
Just send it one. I'll send it.
Okay.
Alright, and this is 4 marks. Alright guys, quiet please. So now I have to look at AR. Guys, too much talking. I have to prove that AR, which is AR over there, is 4 times the length of MB. Where's MB? MB. Okay. Yep. 4 times the length of MB. So I have to prove that that one over there is 4 times as long as that line there. Alright, which means I have to construct this line, which goes there to there. Alright, so now, if I'm doing halves and that kind of thing, I know I'm talking about midpoint theorem. So now, I remember my triangles. I've got this triangle, where I know that that is half the length of that. Alright, so BQ is half of SR.
And S on half of the
So BQ, half,
Yeah, I have eyes.
BQ is, it's 2 times SR.
You see what I get with the eyes.
So if I times SR by 2, I'll get, sorry, half SR. I was writing it first time, half SR. Okay?
S on is half of the.
So, and then I have AQ. Here we go, let's see. I've got SP's here, I've got BQ's, none of them over there. Alright. Alright, so MB is half of QR. So MB is half of QR. There's the triangle. Okay. There's the triangle we're working with now. Need another color. I don't have enough colors. And I've lost my black. Okay. So now I'm working with this triangle over here. Okay, you see it? That's the triangle I'm working with now. So, I know that RQ is half of So I say RQ is equal to 2 MB, and that is midpoint.
Madam, where's MB?
That line over there. Alright. And then MB, so QR is half of AR. So QR is equal to half
So
AR.
half of a half.
Alright, QR is half of AR, and that is proven.
Yeah, then so overall that first one is half of a half.
Yeah. So then, so this one's actually irrelevant. So then I have, guys, quiet please. MB is equal to 1/4 AR. Alright, which is the same thing as saying 4MB is equal to AR. There's my proof. Okay, you guys happy?
After you can die now.
RIP my life.
Alright, so that's it.